So in this video, we'll be looking at the forms for lines, for equations for lines. And actually, we've got three of those. The first one that we'll look at is standard form. Now, standard form looks like ax plus by is equal to c. Now, in this particular case, a, b, and c are actually really going to show up as numbers. And so we just write them as variables to kind of stand in for those numbers kind of generically. But it's the a, the b, and the c that will be numbers. The x and the y will be variables that actually stand for the solutions to the equation. So these are just kind of forms for the lines, and particular examples we'll look at in just a little bit. So as you're looking at these, it looks like there's just a whole bunch of variables going on there. Not really in specific cases. A will be a number, b will be a number, and c will be a number. Okay. So the second form for lines that we have is slope-intercept form. Now, what slope-intercept form looks like, we have y all by itself on one side, and then on the other side we have mx plus b. So again, in this case, what are the numbers going to be? M is going to be some number, and b is going to be some number. And so that's what we'll have in this particular case. We'll talk a little bit more in just a little bit about what m and b mean geometrically, but for now, we're just talking about, this is kind of an overview of all the forms that we're going to discuss. So the third form that we have is called point-slope form. And point-slope form looks like, again, we've got y all by itself on one side. We have this m, and we've got, in this case, a set of parentheses. The x minus h is going to be in parentheses, and then we'll have a plus k on the end. Now, the numbers that will show up in this case, m will be a number, h will be a number, and k will be a number when we're dealing with a particular equation. And so when we say that these are forms for lines, a form is really there to talk about, we've got a whole big family of equations. So anytime anything happens to look like ax, a number times x plus a number times y is equal to some other number, that equation will be in standard form. And so our forms are just kind of there where you've got all of our equations that kind of look exactly like this, and they are getting dumped into one big basket. And so that's what we really mean mathematically when we're talking about forms. So let's look at an example of what we mean when we say standard form. Again, standard form is going to look like some number times x plus some number times y is equal to some other number c. So let's look at different versions of that, or different instantiations of that form. Okay, and maybe we can begin to identify really what we mean by the form for the equation. Okay, so one example that we have is going to be this 2x plus 3y is equal to 5. Now, when we say it is a form, one thing that we begin to identify in that is, well, what were the numbers a, b, and c in this particular case? And so for the equation that we have, the number that's multiplying x, that's what I mean by the a value. So I have a is equal to 2. The number that's multiplying y is going to be my b value. So in this case, I've got b is equal to 3. And the number that's over on the opposite side of the variables, that number is c. So in this case, c is equal to 5. We can really think of a, b, and c in these forms as being kind of parts in a play. And we may have different actors playing different parts in the play as we would see things. And so here we can really think of, oh, the role of A is being played by the number 2. The role of B is being played by the number 3. And the role of C is being played by the number 5. So here's kind of one example that we might see of standard form. Another example would be maybe something like this: 1/2 x minus 5y is equal to 4. And we can kind of do the same thing as we did up here. Well, what exactly are a, b, and c in this case? Well, we remember again that a is going to be the number that's multiplying x. And so in this case, the role of a is being played by the number 1/2. So the b is actually going to be the number that's multiplying y. And so in this case, the number that's multiplying y is this is the number -5. Now, over here in our form, we have that written as subtraction. So remember that when we have, when we're putting our algebraic terms together, that we are doing that with the operation of addition. And so in our minds, this writing subtraction is a bit of a shortcut or an abbreviation for really writing plus a -5 times y. And so that subtraction sign is more of an abbreviation than really the operation there. So when we're looking at it, we're really reading that as a -5 that's multiplying the y. So the role of b is being played by -5, and the role of c is being played by 4. So kind of one more example of that is that we have x plus y is equal to -7. Now, what does it look like when we don't have any numbers that are multiplying it? Well, now we come back to what can we multiply, what number can we multiply a number by and not change it? Well, that would be 1. And so if a coefficient or a number is not present there, we really imagine that one as being 1. So in this case, the role of a, the number that's multiplying x, is being played by the number 1. The role of b is being also played by the number 1, and the number c is actually being played by the number -7 in this case. And so in this case, let's see kind of the same thing when we talk about slope-intercept form. And so slope-intercept form is going to be our y is equal to mx plus b. So let's look at a few instantiations of that particular form so that we can get an idea of what's going to be a number, what's going to be a variable when we see these forms for lines. And so the first one that we have is y is equal to 2x plus 3. And again, what is making this form this form? It's the fact that we have y all by itself. So y is all by itself on one side. And over on the other side, we have some number times x, either plus or minus some other number on the end. And so what makes the form is exactly that. Y is all by itself on one side, and on the other side, we have some number times x plus some other number. And so now we can do the same thing as before. Well, let's see what roles and characters are being played by what numbers in this case. Well, in this case, we have two roles up for grabs. We have the role of m, which is the number that's multiplying x, and we've got the role of b, which is this number that's on the end. And so in this case, what we have is that the number multiplying x is going to be 2. The number that's being added on to the end is 3. And so the role of m is being played by 2. The role of b is being played by 3. Okay. Another example is if we just had plain old y is equal to -2/3 x. Okay, so what happens in this case? Well, in this case, we have some number that's multiplying x, and that number is -2/3. So our role of m is being played by the number -2/3, but if we just look at the equation, it doesn't look like we're adding anything onto the end. Well, what number can we add on to any other number and not change it? The answer, 0. If I add 0 onto anything or subtract 0 from anything, nothing happens. And so if it doesn't look like that I'm adding a number onto the end, it's the same thing as adding on 0. And so in this case, the role of b is being played by 0. And finally, for the third example that we have, suppose that we have y is equal to 5x minus 7. So again, we're looking the form, y is all by itself on one side. On the other side, we've got some number times x, either plus or minus some other number. And so what do we have here? Well, that's exactly what we've got. So we have slope-intercept form. So what is being played by what numbers? Well, the number that's multiplying x, that's my m. So my m value is being played by the number 5 in this case. And then I'm adding on some other number. Well, again, this is my subtraction abbreviation that I've got going on here, that I might write it with a subtraction sign, but what I really mean is that I'm adding on a negative 7. And so I'm seeing that as an abbreviated negative 7, and so my role of b is being played by negative 7. Now let's look at our third examples where we have our point-slope form of the line, which again, these are looking like y is again all by itself. And then on the other side of the equal sign, we've got an m, we've got a set of parentheses, x minus h, and then plus k. So let's look at some instantiations of that particular form. So the first one, let's suppose that we have something that looks like y is equal to 2 times the quantity x minus 3 plus 5. Okay. So again, this one is maybe a little bit different than the last one. When we start identifying these things, we have 3 characters to identify. We've got m, we've got h, and we've got k. Now, where this is a little bit different than the last one, we're assuming that our form is x minus h. And so here, we're assuming that that operation starting there is already a minus sign. So that we're assuming that we already have this kind of subtraction sign already written there. And so when we go to start identifying the characters, well, the number that's multiplying the parentheses on the outside, that's our number m. So we've got the role of m is being played by the number 2. Then inside, it's x minus some number. Well, x minus the number 3 is there. So the role of h is being played by 3. And then finally, the number that's being added onto the end, well, number added onto the end is my k, so the role of k is being played by positive 5 in this case. Now our second example, suppose somebody gives us y is equal to negative 1/3 times the quantity x plus 1 minus 7. So now, what numbers are playing our particular roles? Well, again, we've got the number that's on the outside. The m is going to be our number negative 1/3. So the role of m is being played by negative 1/3. Inside, we have x plus 1. Now, inside, that is what we really wanted from our form was a minus. And so what's kind of happening in that case is that we have, well, it's kind of our subtraction abbreviation again, in that we've got x plus 1 written as x minus the negative 1. So we've really kind of got 2 abbreviations going on here, which really just gives us the positive 1. And so it may look a little bit weird in this case, but because it's x plus 1, our role of h is being played by minus 1. And the reason for that is because we can write x plus 1 as x minus the negative 1. And then finally, our number on the end, that we are adding the number on the end. So here it's a minus 7, so we're subtracting. This is our subtraction abbreviation in this case, and so our value of k is being played by the number negative 7 in this case. And so one question we can ask ourselves now is, how exactly are each one of these related to the geometry of lines? So in these discussions, kind of the picture of all possible XY solutions for these will be just a straight line. And so how do the forms for these things impact the particular line that we're talking about? And so for that, let's start looking at the slope-intercept form. That's probably the easiest one to start with. So when we've got our equation here, then kind of a picture that we have, well, our solution is going to be just this straight line. And then we've got a y-intercept, and remember that the y-intercept is just the point at which we cross the y-axis. Well, that's actually given by the point 0b. And so what does b tell us? B tells us the value at which we cross the y-axis. Then for the other part, the other character in our form that we have here, the number m is standing in for the slope of the line. And kind of just to remind you of what the slope is, if we pick any 2 points on that line, the slope, if we want to imagine moving from one point to another point, the slope, or the change in x, is just how far we would move horizontally. The change in y is how far we have to move vertically in moving from one point to another. And the slope is then just the ratio, the fraction of the change in y divided by the change in x. And so geometrically, m is telling us the slope of the line, and 0b is telling us what the y-intercept is. So we can kind of begin to just look at that equation, identify the form, and we've got an idea of what the picture of solutions actually looks like without having to do a lot of work. And that's kind of one of the big ideas behind these forms, is that once we identify the form, we know what those particular characters in our form do, how they impact the picture, and so it gives us a kind of a fast way of going from the equation to the picture of solutions, to the graph of the equation. And so now, kind of the next one is going to be the point-slope form for the line. And so the point-slope form for the line, again, remember, looks like our y is equal to the quantity m times x minus h plus k. So what does this have to do? Well, again, our picture of solutions will just be a straight line. Now, how this is just a little bit different than our point-slope form, hk, so the value, so h is going to be the x coordinate and k is going to be the y coordinate for any particular point on the line. And so it doesn't have to be the y-intercept back here. If we happen to know any point on the line, then we can kind of use this form for the hk values. Now again, our character of m, in both of our instances of our lines, when m shows up, he's going to be the slope. So again, if we have 2 points on that line, we look at how far we move horizontally, that's the change in x. How far we move vertically, that's going to be our change in y, and the ratio of those, change in y to the change in x, is just the slope of our line. And so our last form, our standard form, y is equal to, or ax plus by is going to be c. So what happens with the geometry of this one? Well, once again, our solution is going to be just a straight line. So all of our x values and y values that satisfy that equation are going to just be a straight line. And the pieces of information that we can get off this, we can get the y-intercept, we can get the x-intercept, and we can get the slope from this standard form. Now the x-intercept is just going to be just the x value is going to be the number c over a. and our y value is going to be 0. So remember, for the x-intercept, all y values are going to be 0. So our x-intercept, c over a, comma 0. Our y-intercept, so where we cross the y-axis, is going to be 0 and c over b. And once again, our slope, which was just our change in y over change in x between any 2 points on that line, our slope is actually going to be given by negative a over b. Now, with that, these forms enable us to go from the equation to the line, and depending on what information we might know about given the picture, we might be able to go from the line, from the picture of the line, to an equation for the line. And how we'll do that's kind of going to show up in videos a little bit later, so stay tuned for that.